Well, so you can see this is the decision tree machine learning algorithms. That is, I put some light here actually in the document that I've made some. I put some points here or some I've some drawings as well. So here you can see the root node, the branch node, and the leaf node. Okay, so yeah, now. Now let's explain all these in details. Well, so instances are classified starting at the root node. Here you can see this is the root node, this part. Well, now so instances are classified starting at the root node and sorted based on the feature values, right? So this is a sample decision tree. This is a sample decision tree. You can see this is a decision node. This is a decision node as well. This is a subtree. This is a branch node, more precisely. This is a root node with the highest information gain. I'll explain information gain later on. That is, I'll explain entropy as well. So here you can see the leaf nodes as well. So all the leaf nodes. Okay. Also this one, the left picture, you can see the left picture is also a decision tree. So this is an example of a decision tree for the training set, and DT or decision tree are extensively used in different computational fields to classify data. The reasons behind the wide acceptability of DT learning algorithms are the flexibility to apply in a wide range of problems. An interesting and important property of a decision tree and its resulting set of rules is that the tree paths or the rules are mutually exclusive and exhaustive. This means that every data instance or record or example of picture or case is covered by a single rule. According to Peer et al., a research group, DT or decision tree machine learning algorithms combined with ensemble methods. And it can provide better results in terms of predictive accuracy and significantly in the context of high throughput data sets. Tree-based methods are also highly scalable from a computational point of view. Yeah. So by using the DT depicted here, actually I think the instance, this instance actually. So let's talk about this decision tree as a sample one, and this would start to the nodes, which would classify the instance as being positive represented by the values. Yes. So yes means positive, no means negative. Well, so the feature that best divides the training data would be the root node of the tree. There are different methods to extract the features that best divides the training data, such as information gain and Gini index. So information gain is basically the more is the information gain, the lesser is the entropy. Entropy is mean the randomness or chaos in this decision tree. Well, so let's explain some learning set of rules of this DT ML algorithm. So it's also possible that decision trees can be translated into a set of rules by creating a separate rule for each path from the root to a leaf in the tree. However, rules can also be directly induced from training data using a variety of rule-based algorithms. So here, an excellent overview of existing work in rule-based methods. Here you can see, and the classification rules represent each class by disjunctive normal from DNF. A statement is in DNF if it is a disjunction or sequence of ORs consisting of one or more disjuncts, each of which is a conjunction and the end of one or more literals. Below is an so you can see the this below. I mean, this is the table you can see it on the screen of my desktop on the computer. So these are some comparison between the most used arguments, rather most used algorithms in decision tree rather. Okay, now you can see some Gini, the methods is these, and now the Gini index, and the criteria. Here is the entropy information gain. Info gain is basically information gain. Here is chi-square, here is chi-square rather. Here is pruning, the pre-pruning using a single pass algorithm. Here is pre-pruning using the single pass algorithm, pre-pruning using chi-square test for independence, then post-pruning. Now here dependent variable, categorical or continuous, categorical continuous, 4.5. Now CHIID, that's categorical, again categorical for quest. So here input variables for the method, and then comes CIT cut into categorical or continuous. There's 4.5 as well. That's categorical or continuous. Here CHAIG, that's categorical or continuous here as well. The quest is the same goes for quest as well. So now here for methods split at each other, and then CHI binary split can linear combination. Then comes 4.5 multiple, then CHAID multiple, then quest for binary split or linear combinations rather. Oh well, so that's fine. Now the core difference between heuristics for real learning algorithm and heuristics for decision tree algorithms is that the latter evaluate the average quality of a number of disjointed sets, while rule learners only evaluate the quality of the set of instances that is covered by the candidate rule. Well, one of the most useful characteristic of the rule based classifiers is the comprehensibility. In order to achieve better performance, even though some rule-based classifiers can deal with numerical features, some experts propose those features should be discredited before induction. So as to reduce training time and increase classification accuracy. Now let's talk about statistical learning algorithm. Statistical learning is a framework for machine learning drawing from the fields of statistics and functional analysis. Well, statistical learning theory deals with the problem of finding a predictive function based on data, and it has a good number of applications in the field of AI. The major goal of statistical learning algorithm is to provide a framework for studying the problem of inference, that is obtaining knowledge, making predictions, and making decisions by constructing models from a set of data. Now, Bayesian networks are the most well-known representative of the statistical learning algorithms. Well, a good source for learning Bayesian networks or BN theory is where our readers can learn applications of BN or Bayesian networks theory. Well, now statistical methods are characterized by having an explicit underlying probability model, which provides a probability that an instance belongs in each class rather than simply a classification linear discriminant analysis or LDA. So linear discriminant analysis, this LDA, which was developed back in 1936, and the related pieces linear discriminant are famous methods used in statistics and machine learning ML to retrieve the linear combination of features which best separate two or more cases of objects. The purpose of discriminant analysis is to classify objects or nations, people, or customers as well, into one of two or more groups, based on set of features that describe the objects. For example, gender, marital status, marital status, income, height, weight, etc. Now, another method for estimating probability distributions from data is maximum entropy. According to the Bayes theory of maximum entropy, if nothing is known about a distribution except that it belongs to a certain class, then the distribution with the largest entropy should be chosen as the default. Now, Naïve Bayes classifiers, NBN, Naïve Bayesian networks, NBN. So basically, Bayesian networks are widely used to perform classification tasks. Naive Bayesian networks, or NBN, are very simple Bayesian networks which are composed of directed acyclic graphs, with only one parent representing the unobserved node, and several children corresponding to observed nodes with a strong assumption of independence among child nodes in the context of their parent. Well, according to a research group, the independence model Naïve Bayes is based on estimating R. R is basically the fraction of P T as X or pizza X, and here comparing these two probabilities, these are two probabilities actually. Comparing the two probabilities, the larger probability indicates that the class label value that is more likely to be the actual label if R is greater than 1, that predicts I else predict J. So the links in a Naïve Bayes model are directed from output to input, which gives the model its simplicity as there are no interactions between the inputs except indirectly by the output. Well, an advantage of the Naïve Bayes classifier is that it requires a small amount of training data to estimate the parameters necessary for classification. Okay. Now let's discuss the Bayesian networks or BN in greater detail. Well, so Bayesian networks BN are graphical models that are used to illustrate relationships between events or ideas to infer probabilities or uncertainties associated with those ideas or events. Information retrieval predictions based on limited input or recognition software is some main applications of BN or Bayesian networks. Well, the Bayesian network structure is a directed acyclic graph DAG, that is directed acyclic graph DAG, and the nodes in S are in 1 to 1 corresponds with the feature X. The arcs represent causal influences among the features, while the lack of possible arcs in S encodes conditional independencies. Moreover, a feature node is conditionally independent from its non-descendants given its parent x1 is conditionally independent from x2. So that's fine. Now I'll talk about instance-based learning, IBL. So I'll talk about instance-based learning now. Now about this learning scheme, it can be described as a lazy learning algorithm, as they delay the induction or generalization process until classification is performed. These algorithms require less computational time during the training page and then other eager learning algorithms such as decision trees, neural and Bayes nets, but need more computation time during the classification process. Nearest neighbor algorithm is an example of our NN algorithm, that is RNN. So many KNN algorithms are there, and is an example of instance-based learning algorithms. And a research group, Aha and Day et al. Discussed the instance-based learning classifiers. Now KNN that I was talking about just a while ago now. So KNN or K nearest neighbor classification is one of the most widely used method for a classification of objects when there's little or no prior knowledge about the distribution of the data. Now KNN is a good choice to perform discriminant analysis when reliable parametric estimates or probability densities are unknown or difficult to determine. Now KNN is an example of supervised machine learning algorithm, or SLM algorithm, supervised machine learning algorithm, in which the result of new instance query is classified based on majority of K nearest neighbor category. The core function of algorithm is to classify a new object based on attributes and training samples. So here the classification is using majority vote among the classification of the K objects. For example, we have conducted a survey on the consumption of any particular item to know its worth in the market. Well, so the outcome yes or no is dependent, on the variable values of x1 and x2. So if we want to know the outcome of that combination which is not available to us. So for example, when x1 equals 4 and x2 equals 8, so then without doing a lengthy exercise of conducting surveys, we can predict the results by using k-NA or k-nearest neighbors classification method. Well, so that's about instance-based learning or IBL. Now I'll shift the focus to focus on the support vector machines or SVM algorithm. Yeah. So these are basically supervised set of algorithms, So now SVMs or support vector algorithms are a set of supervised learning methods which have been used for classification, regression, and outliers detection. So there are a number of benefits for using SVM, such as number one, it is rather effective. It is effective. In high dimensional space. Number two, uses a subset of training points in the decision function called support vectors. So it is also a memory efficient. Number three, it is versatile because holds different kernel functions can be specified for the decision function. Common kernels are provided, but it is also possible to specify custom kernels. Now, most real-world problems involve non-separable data for which no hyperplane exists that successfully separates the positive from negative instances, or yes from known instances rather. In case of decision tree earlier on that I had explained earlier in the video. So in the training side here, in the training side, one good solution to this inseparability problem is to map the data onto a higher dimensional space and define a separating hyperplane there. This higher dimensional space is called the transformed feature space as opposed to the input space occupied by the training instances. Well, so in order to get better results, the selection of an appropriate kernel function is very, very important, since the kernel function defines the transformed feature space in which the training set instances will be classified. Some new kernels are being proposed by researchers these days, but given about now here that I've already explained some kind of methods here, algorithms as well. So that can be done. Now, some popular kernels that can be explained here, or that can be exemplified rather, are linear, polynomial, radial basis function RBF, and sigmoid as well. Okay, now that's fine. Okay, now so that's the idea of SVM or support vector machines algorithm. Now let's delve into deep learning, DL. So what is deep learning? Now, deep learning is a subset of machine learning, which in turn a core subset of the artificial intelligence or AI. So deep learning and neural networks. So now deep learning, the use of deep artificial neural networks, so that basically resembles the human brain in machines, human neuron networks in machines, or some networks. So that's kind of deep learning thing. So the use of deep artificial neural networks has gained popularity over the last few years in pattern recognition and machine learning. Most of the popular deep learning techniques are built from artificial neural network, ANN. Deep learning can be defined as a model, for example, neural network with many layers trained in a layer, where spatial deep learning has had a tremendous impact on various applications such as computer vision, speech recognition, natural language processing, and crawling deep web. Now, our research group, Xami et al., have discussed challenges and new applications of deep learning in this study. Now, deep learning has also been successfully implemented in industry products that ultimately take advantage of the large volume of data. Top information technology IT companies like Microsoft, Google, Apple, Yahoo, Baidu, Amazon, and Facebook, other etc., who collect and analyze massive amounts of data on a daily basis, have been investing good on finances on deep learning related projects. For example, Apple Siri and Google's voice search offer a wide variety of services, including weather reports, sport news, and search to user questions rather, and reminders, etc. By utilizing deep learning algorithms, currently these two applications support a wide range of spoken languages as well. Now, supervised machine learning methods are being applied in different domains due to scope of. Now, it's very difficult to discuss the strength and weakness of each algorithm of ML. In this video, the selection of algorithm in ML is mainly depends on task nature. The performance of SBM and neural networks, is better than when dealing with multi-dimensions and continuous features, while logic-based systems tend to perform better when dealing with discrete or categorical features. For neural network models and SVMs, a large sample size is required in order to achieve its maximum prediction accuracy, whereas NB may need rather a relatively small data set. For the last few years, deep learning or neural network is becoming a mainstream technology for a variety of application domains, like face detection in smartphones as well. When you unlock your phone, unlock the smartphone, also it can be done by detecting the face of the user, speech recognition as well, and detection as well, speed object recognition, natural language processing, NLP, natural language understanding, NLU, and natural language generation rather, NLG, and robotics or robotic process automation, RPA, robotics process automation. So I believe that the challenges posed by big data will bring ample opportunities for ML and ML algorithms, and especially to deep learning methods like neural networks, ANN, CNN, like convolutional neural network, artificial neural network, and others as well. So that's it about the supervised algorithm. I've somehow I've somewhat in greater detail I've explained the types of ML, like supervised learning, semi-supervised learning, and unsupervised learning, as well as reinforced learning, and their pros and cons. So that's it for the categories of ML. Now let's talk about let's compare the supervised, semi-supervised, unsupervised, and reinforced learnings with each other's pros and cons. Okay, well.